Hello, this is Professor Charles, and welcome back to our system that I presented in real life, but now this is on paper for you people that learn visually instead of listening, because I feel bad for those people that can't listen. Okay, so this is our system right here. Okay, just to keep in mind, these are two separate strings. There's one string right here, and one string right here. Okay, so we have the box. The box right here, or it was a bottle in the actual, but since I can't draw a bottle since I don't have that skill and I'm on mouse, it's kind of difficult. So I made it a box, okay? And I said that the box weighs one Newton, okay? We're able to, if you wanted to find the actual weight, you would use Newton's second law, which is sigma F equals ma, and then since this is Fg is known as mass times gravity, right? So in these terms right here, all you have to do is take the mass of the box times the acceleration of gravity, which is 9.8, and then you get your Fg. Okay, and that is the weight of the box because Fg is also known as weight. So that's why I say that Fg is weight. Okay, so and since this is hanging on to this rope right here, we know this is tension, and they're contact forces. So tension goes upward, and the box goes downward. And since they cancel out and they're stationary, that means that the weight of the box is equal to the tension. Now, since we have two strings, right, the tension right here gets split off into two. So this is T half, and this is T half. Now, and since this is another string, this is a different story. This is T half right here, but it will not be T half right here, because this is a new string. We would have to split up T half onto these two strings. So this is T fourth now, because a half of a half is a fourth. This is T fourth. And since this is one whole string, since this is T fourth, this also has to be T fourth. Okay, so effort. Let's talk about effort. Effort is the amount of force I apply to the system, which means if I were to pull the string downward, right? But the thing is, your effort is only going to be a fourth of how much the box weighs, because the tension right here the tension is equal to the amount of force you apply. So therefore, you would be applying 1/4. So effort would be equal to T4, right? And since we know that T is 1, just because the weight of the box is equal to T, your effort is equal to 1/4. So and so your force basically is 1/4 of the whole system, or not the whole system, but the amount of tension there is from the box to the third pulley, which is right here. Now, okay, let's go on to mechanical advantage. Mechanical advantage is basically the force of the load, so the weight of this divided by the force of the effort. And so, since we know your effort is 1/4, we would make this equal to 1, which is the weight of the box, right? The force of the load, divided by 1/4, which is the force of your effort. Since your force is going to be 1/4 of the tension, and the tension is equal to 1, so therefore 1 divided by 4 is 4. Or 1/4, 1/4 actually, my bad. And then 1 divided by 1/4 is 4. Now, we have ideal mechanical advantage. So when I pulled down the rope, right, and this went all the way up until it could not go anymore, I measured it and it went 56 centimeters, correct? Now, when I pulled down, since this went 56 centimeters, the box, when in real life, when I pulled it, it went up 14. Since it goes up 14, and this went up 14 centimeters. This is when I pulled all the way down, and this pulley right here came all the way up, and I could no longer pull. So we take the distance of the effort, which is how much I pulled downward. I pulled down 56 centimeters, and I divided by the distance of the load, which is 14. And 56 divided by 14 is 4. Now, if efficiency, it is the mechanical advantage, which is 4, divided by the ideal mechanical advantage, which is 4. So this is equal to 4 over 4 which is equal to 1. But the thing is, if we were to convert 1 into a percentage, that says we have 100% efficiency. But that's just not possible. The reason why is there's so many factors you have to take into account, and one of the few factors that I know is the friction from when I pull down, because there's friction in the pulley, right? And then we also have the mass of the pulley that we also have to take into account. So those two factors itself will not give us an efficiency of 100%. There's just no way it's possible in real life. And this concludes my presentation on the pulley that I did in real life. Thank you for watching. I hope you enjoyed it.